Guys, any question from last class? No questions? Okay. Uh, so please, that's good.
Professor, I had a quick question.
Yes, please.
If you could go over the arithmetic expression from chapter 3 real quick, just so you go over it.
Yes, we can go, no problem. Arithmetic expression. Yes. Um, do you see my screen?
Yeah, I think it's slide 13 had the example.
Okay, so just a minute. Let me close this. Slide 13. Okay. Okay.
So like, how do we break down the problem for this example?
Oh, so, okay, let me. It is exactly the same way if you revise this thing, you see the polynomial. So we exactly did that the same way. Let me show you how we did this. So we are saying that these are the uh, four few rules here. So now we are saying that first we pick two. So let me first I solve this for you. If I solve this, exactly the same thing will solve. So first I said, okay, 2. And this is from rule 1. Rule 1 says any number, positive or negative, is in are in arithmetic expression. It's good, yes?
Yeah.
Okay. So now we are saying we find 2 from rule 1 that this is in arithmetic expression. Same way we find 4 from rule 1 that it is in arithmetic expression. Okay, by rule 1. And now we have in arithmetic expression, now we have two terms. One is 2 and one is 4. One is 2, one is 4. Okay. So now we are saying, let's say how we handle two terms. Here, if you see rule 3, it is handling two terms. It says if x and y are variables, placeholder. So you are saying if x and y are in arithmetic expression, the following words are also in arithmetic expression. You can put plus sign with them, minus sign, star sign, slash, or double star, mean exponent. So do we have plus here? Yes, we have plus here. So we are saying that x plus by rule 3, part 1, we prove that 2 plus 4 is also in arithmetic expression. Okay, and now we have 2 plus 4. So now we see that we see that it has parentheses around that. So do we have any rule which talks about parentheses? It says yes. If x is in arithmetic expression, the following words are also in arithmetic expression. And so you put parentheses around x. So we consider this whole term as one, and we put parentheses around that. So now this is our x and we put parentheses around that. So this way we prove that 2 plus 4 is an arithmetic expression. And then
That makes a lot more sense.
is good. So now
Yeah,
we
that's good.
follow the same logic, and we pick, because now we know that from where we will start. We cannot start from this star or this bracket parenthesis. We need to start from this inner thing, this thing, because if we start this, then it will grow and then we can make this. So exactly, first we think that 9 is in the in arithmetic expression by rule 1, 3 is in arithmetic expression, 9 minus 3, x minus y. So we have, you see, x minus y we have here. Look at this. And then by this, and then we consider this as x. No, not yes, this as x, and we put parentheses around that. Now this is done. And now we put 4 as arithmetic expression, and then we consider this as x, this as y, and if you see x slash y is in arithmetic expression. So 9, this thing as arithmetic expression. And now we consider this as uh, one term, and then 7 in arithmetic expression, and then this is one term, and 7 is x, this is y, and 7 star y is in arithmetic expression.
So it just keeps growing until you have the original equation.
Yes. And then we consider this whole term as x, and then we put parentheses around that. So if you see that the way we did this, it's exactly we follow the same logic, and we start drawing this. And then once we done this, so then again life is very simple now. So now this is 2 plus 8, and so 2 and then 8 and then minus, and then put parentheses around that. Oh, sorry, plus. And then you need to put uh, actually this thing, I think there is 9 minus 3 minus 4. Yeah, no, this is good. This is good. So then we consider 4 separate, and this x, this y, and star, and then this whole thing as x, and we put 1 here, and then this one is will be y and x minus y, and this way you will get the whole term there by just by using these rules.
All right, that makes sense. Thank you.
No problem. So this is very good that you ask a question. Okay. So anybody has any other question, guys, from last class? So let me close. Today we will start chapter 4. So this chapter is start recording. So this chapter is about regular expression. So guys, this chapter I request you, if we finish this in today class, it is good. If we do not finish this in today class, this goes to the next class. So these coming, at least this chapter 4, and the coming uh, uh, one more chapter, I believe chapter 7. So these chapter especially chapter 4, and I will let you know that with other chapter. Do not miss this class, and do not miss this class. And I want you, do not let me go to the next slide. If you have any single confusion in any of this slide of this chapter, if you do not understand this chapter, you will not understand the whole course. Whole semester is built upon this chapter. Okay, and this will have high impact on your assignment, on your first exam, on the coming quizzes. Okay, so this is a very important chapter. You can say that. So now I try my best to go slow, but it is my request. If you have any question, anything you don't understand, do not let me go to the next slide. Stop me there. Ask me a question. Okay, and I think that you should do this. Okay, so now and I try to see the chat message also, but sometimes I need to close this because to show the whole chapter. So please try to use your mic to speak. And if you have chat message and I somehow did not get that, you send the message. So please, anyone else, if you see, let me know that someone is asking any question in chat. Okay. Okay. Regular expression. So far you see 4 methods, 4 ways to define the language. First way is express or define the language using English sentences. Second way, you try to create all possible words. You start from the smallest word, and then you create the second word and the third word and the fourth word, and this way you put dot dot dot, and you show the pattern how you generate the language. And then this will tell you anyone else that okay, he followed this pattern and all the future words will be generated by using this pattern. Okay. Third way is algebraic expression, x raised to power 2 raised to power n or whatever, whereas n is equal to uh, any 1 2 3 4 5 or so. So this is algebraic expression. And then yesterday we finish recursive definition, where I explain the recursive way of defining the language. We have a template. We always follow that template. First we define the base case, which should be concrete. It should not include any variable or something. And then we generate the rules which follow the base case, and from the base case how we generate the next words. Okay. And then rule number three, there is no rule other than rule one and rule two. Very nice. But this is now regular expression. This is another way, and which is very solid way of defining the languages. Okay, so let's see how we do this. So this is a new method to define the language. Um, and you are very much familiar when I say what is alphabet, what is word, what is letter, what is language. You are very much familiar with that. We did this in chapter 2. Okay. So now we are saying that we have summation is equal to x, something like this. Okay. And we want to apply clean star on that. We apply clean star here on that. So it means that we will try to apply permutation, all possible combination of x with itself plus this new language, which is clean star, must have lambda also there because this is the property of clean star, and we did this. And then, so now this is not new. We already know this before. Okay. And now what we are doing, we have a summation here, and we apply clean star property on the summation. Uh, so we also write the same thing here. We can say that we have x actually, and we apply clean star on x, and actually it has the same meaning, and this is equal to this. So now this is the same thing, but we replace mission star with x star. So we want to know that how we get this. So it means that now if I write x star, what does it mean? It means lambda x, 2x, 3x, and so on. Okay, so this is what we understand now, that if you have a alphabet x and you apply clean star property on that, it means all possible combination of x with itself plus the lambda will be there because we are applying clean star, and this is the property of clean star. Very nice. And now you can, let's see a language. So we see this, we have an alphabet and we create a language. Now you know that clean star is not only used by alphabet, it can use on the language, it can use on the word, it can use on the letter, it can be applied anywhere. Now we are saying that we have a language, and our language is a very simple language, which is just composed of two words, xx and 3x. That's it. And we are interested to find s star on this. So we apply s star here, and this is lambda, and the first basic building block, first word, second building block, second word, and then all possible combination of x with itself and 3x with itself and with each other. So whatever all the possible combination, 4x, 6x, 5x, all possible combinations. So we write this one. We already saw this in previous lecture. And now we are saying that uh, we what we are doing, we are applying whatever the set s, we apply star on that. So what is set s? Set s is this. So we are saying that okay, xx comma xxx clean star is equal to this. So it is nothing, we just replace s with its set, and then we find the clean star on this set. And actually we are doing the same thing before, but before we were writing the language name, and now we write the set itself. That's it. So what does it shows that Both way of representation is good. There is no problem with that. You can do this on single letter also, like you have X star, and you and will be used to indicate some sequence of X, maybe none at all. So now if I have language X star, it means this, as I just explained here, or informally. So when we do not need to write every time language with that, because we know that this is a language. So now we know that this is a language, we know that this is a language, so we do not need to write every time language with that and the bracket close and bracket start and close. So we informally write X star, and we are saying that this is equal to this, and that's it. So far, any confusion here in this slide? No confusion. Very good. You guys listening? Yes. So now we are going to the next slide, and we are saying that, let's say I do not have one letter, I have more than one letter. Then how we write? So I have A and B star. Now you understand what does it mean. So I have a language which has A and B star. So now it so I mean there is a space in between, but when we write here we do not write space there. So it is the common understanding that this is not one word. This is A is a separate letter, B is a separate letter, and B has a so now if you see that here why we put space, just to show you that this star is only on B, it is not on A. So now if you write it this way, so this star does not on A, it is only on B. Okay, so now if you have only A there, then then uh, if you write a language of that, this is only one A. If you have B star there, and I ask you write a language of B star, what does it mean? It means, so how I write the language of B star? Can anyone explain here? Can you help me to write here?
Wouldn't it be like every combination of B and then also lambda?
Yes. So what we write, lambda, 1b, 2b's, and 3b's, and so on. Yes, everybody agree with this? Yes. Okay. So now I want to combine this with this. So this language with this language. So now what does it mean? So here order matters. So we are saying that if I write A, B star, so order matters here. All the words, I combine two languages and I make a new language. So this the new language, what are the rules and restrictions what this new language will face? Which respect? So it is that all words will have, so now let's say I combine A with lambda. So I have A lambda, and you know that when lambda concatenate with any letter, it will vanish. So I have only A here. Okay, I combine A with two B's, one B, I have A B here. A with two B's, I have A B B here. A with three B's, A B B here, and then and so on. So now we have a new language, and this language is the representation of A B star. Not so now this star is not outside the bracket. If it is outside the bracket, it has different meaning. It is inside, it is only on B. Okay, so now it means that all words of this language will have A at the leading position, and it may have B, it may not have B. If it has B, it will be in the following position, and we do not care how many B's will come. Okay, so this is the English representation of this language. If I ask you to write the English definition of this language, this is the English definition of this language. This language does not have, so now my question with you, do you think that this language, it will have lambda or not? Anyone, do you think that this language will have lambda or not? AB star. Uh, who is speaking?
Jacob.
So Jacob, how we have lambda? Can you please explain me this?
It's always in
It's always
constant
in B
order.
star. It's always in B star. Very nice. But I'm not talking about B star. I have A B star. So now, when you have A B star, so what does A does not have any sign or symbol on top? What does it mean? A always be there. Yes, A always be there. But B star has sign, B has a star on that. It means B may be lambda, B may be 1B, B may be 2 Bs, B may be 3 Bs, B may be as many Bs. Or may there is no B because we got lambda from B star. But A has no sign on top of that. So so there is no way you will get lambda from A. Okay, this is the, are we, do you understand this thing? Yes, Jacob?
It makes
Okay.
sense because there's always going to be an A there.
Very nice.
Yeah.
So now we are saying that if that is the case, so A will always be there. So now lambda will not vanish any letter. Lambda itself will vanish when it concatenate with any letter. So there is no way we will have lambda in this new language. Make sense? Because if I just talk about B star, yes, it has lambda there, B there, two B's there, and so on. But I am talking about AB. So A will always be there. Let's say I pick lambda from here. So A lambda, what does it mean? It means just A. Lambda will vanish when it concatenate with A. So A, and then I pick another word B, it will be AB. I pick another word ABB, it will be ABB. So there is no way you will have lambda in this language, but you will have A. So how we, so what is the pattern now? If I write a pattern, what is the pattern of this language now? So now pattern is all words start with A, and you might have B in the word at the following position, you might not have B in the word in the following position. You see, we have one word which does not have B after that, but other words have B after that. But whenever we have B, it must be in the following position. It, you will never see the word start from B. You will always see word end with B, or if it is not, B is not present, then there is only one A. This is one thing. You will never have more than one A in one word. You will always have exactly one A in your word. Okay, so this is basically the way you can express this in English language. Okay, so now if you see this, we did not write anywhere here in the English language of this. So do you understand this? Anyone has any confusion? So Jacob, did I answer your question that why we should not have lambda here in this language? Jacob, do you understand this now?
I do. Yeah.
Okay, that's great. So now, anyone else has any question on this? Okay, so now we are happy with this. So now we are saying that we have this. Uh, so this is about this. So now we are saying that we have this another language which is A, B, and then it has star outside. Okay, so what is this? So now here, when you have star outside, this is not equal to A B star. Okay, this is different. So here it means this whole thing has a star. This whole thing has a star. Again, this A B star does not mean that A star or B star. No, it is not, it does not have this meaning. It means that this thing is one term and it has a star on that. So A star, B star is not the same like this one. Okay. So it is not the same thing. So now when you have A, B star, so now first we so because this whole thing is x is one term and it has star there, so this whole thing has, so now we might have this term or we do not have this term because of star, so we have lambda there. And we have a b there, and then we repeat this term again and again, might be two times a b, three times a b. Now this a b, when it is in parentheses, and it has star outside, so AB will behave as one entity. It will not be behave as A separate and B separate. AB will be, it will always be either repeat as a one entity, AB, 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 like that. Okay, so you will never see any word start with B. You will never see any word end with A. Okay, so it is just A B star, A B A B. It will be like that. So this is a difference between, that's why AB whole star is not equal to AB star. Okay, so this is a difference here. And now if I say that I have A star, B star, so what does it mean? What will be the set of this thing? Anyone? In the parentheses, you have star, separate star on A and separate star on B. What does it mean? Can anyone help me to write the language of this? Austin, you here listening? So can you help me to write the answer of this?
Yes. So it would be lambda, then
Sorry.
AB.
So smallest words.
ABB.
Whenever we write from the smallest word.
Okay, so
Lambda is right. Yes.
then it would be AB, then
So,
then two AABB, and then three A's, three B's.
okay. So can we have only A here?
Sorry, what was that, Professor?
Can we have only A here in this language?
Yes.
Yes, Austin.
Yeah.
We will have, yes, because might be we get lambda, because if you see separately, what is A star? A star is lambda, A, A, and so on. What is B star? Lambda, B, 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 and so on. So might be we pick lambda from here and A from here, because A star, B star, and then lambda concatenate with A and lambda vanish, and we have only A here. Yes, so it is possible that we have only A here in this language. Can we have only B here? Yes, might be we pick lambda from here and B from here and concatenate, and lambda vanish, and we have only B here. But we will never have, uh, whenever we have A and B together, you will never see that A will come in the following position, or you will never see that B will come in the leading position. When you have the both things, you will never have BA, you will never have uh, yeah, BA. So you will never have something like this where the word start from B and end with A. You might have only B there, you might have only A there, but you will never have a word which either start with B or end with A. So it is not the possibility. Okay, and then but you can have as many combination of A's there, one A and thousand B's, thousand A's, or one B. It's up to you. So you will have one A and two B's. So anything is possible. It's not necessary that, because now Austin, do you need to understand this thing? If you just write this answer of this question, which you write lambda A B A B B, so this will lead us to the wrong conclusion. So this gives me this impression that it will have lambda and it will increase with the same number of A's and the same number of B's. But actually, this is not the case. You might have only A. So now, if I be at your place and I want to write this language, I rather start writing this way. I will say you start very well. Lambda is good. I will say then A only, then B only, then A, then B, then A B, and then I say A B, and then A, B, B, and then three A's, and then three B's. So this way I can, so now you see here now I have all possibilities that one A, one B, two A's, two B's, A and B, and more than one A and one B, more one A and more than one B. So all possible combinations. Now this is a good pattern. And on this pattern, if you follow, you can generate all the possible word of this language. Make sense?
Yes, Professor.
Very nice. So now I have a question with you guys. We saw three things. One is uh, uh, actually I no, no, no. What's this? Oh, how high? How high? Okay. I want to actually add a new slide in between. So then, okay. So now if you see this, okay, this is good. I have a slide now to write something. So now if we are saying that if this is a case, we saw three things now. One is that what is A B star. Second thing is A B whole star. Third thing is A star and B star. And these all three things are different from each other. And if you understand this, it means that we are good. I should go to the next topic. Okay. So now we are saying that, let's say I have I have this language which is X and this language, and I want you to write this in this format. How we can define this in form of regular expression. So this is regular expression. So guys, so this is what you see. This is regular expression. This is one regular expression. This is another regular expression. This is another regular expression. So this way of concise way of writing the whole language. Now you can see this represents the whole language actually. So A and uh, A B and A B B and so on. So this represents the whole infinite language. But by writing so what something which is infinite in nature, you write that in very concise way of A B star, and that's it. So this is called regular expression. Okay, very nice. So now I have this language and I want you to write the regular expression of this language. So now let's see, we have some answers given here. Let's analyze these answers, that whether they make sense to us or not. So now, first of all, we need to see that what is this language. This language says clearly lambda is not there. Okay, very good. It has 1x and then 2x and then 3x and then 4x, and it says so on. It means all possible combination of x's. And we saw that in our previous chapter that if you do not have lambda and all possible combination of the language, you can represent that by the positive closure. So this very nice, it represent this language. So now if you write the regular expression, so how I ask you a question, I will either give you English description of the language, or either I give you this way and I will ask you, please write the regular expression of this language. So how you write the regular expression of this language? X plus. X plus means here no lambda in this, but all possible combination of x. Okay. Are we happy with this? To lambda. So now we are saying that this is the regular expression of this language. Okay. Can we write x star? We cannot write x star, because when we write x star, this will have lambda there, whereas this language does not have lambda, so we do not write x star only for this. Now look at this one. So it says x star. So do you think that this is the valid regular expression for this language? So we have this all regular expressions. We need to figure out which regular expression is valid for this language. So we figure out that this is valid. This is good. Now check this one, whether the x star. So anyone, all of you, is this a valid regular expression for this language or not?
Yes, I think so.
Very nice. It is valid. How it is valid? X star will give you lambda and everything. And but because we have one x before, it means that this star is not on this x. And because this x does not have any symbol there, it means you will have x every time. You will never have lambda in this set. It is exactly the way you saw this language. So it means that it will equal to 1x. Might be we get lambda from here, but 1x will always be there. Then we get, and this x will always be there. And then variation will come from this part. So then might be 1x, so 1x from this, or first x, and then from this part 2x, and so on. And this will be your valid regular expression for this language. So this is valid. Very nice. So now I will go for this one. Do you think that this is valid or not? Anyone?
I think so.
It is valid, because we don't care. You know that when you have 1 star or 2 star, it does not make any difference. Yes. So now if you have 2x star, it does not make any difference here, because whatever the thing you will get from here, the same thing you will get from here. But x gives you guarantee that x will always be there. 1x will always be there. We only need guarantee here of 1x. We just do not want to include lambda in this. And then we have 1x there, and this is valid. This is also valid. 1x is there. X plus gives you guarantee that 1x will be there, and x star will gives you lambda and all those things. But when lambda can concatenate with x, it will vanish. So this is the same thing by writing in other way. And this is also 1x is always here. So it does not matter that from where you start, where you end, and it has star there or not, but x will always be there. Okay. So now, yes, please.
Does x star and x star, is that equivalent to x star star? Is that what you're saying?
And x star is equal to x. No, I am saying that and in this, because both are x, so it is equal to this one. But when this will change, it will not equal to, then it is different thing. Here, yes, it is equal to the same thing, no problem. Make sense? Because if you see that x star will give you all possible combination, and this is also the same set, x star, and x double star is the same thing. So now if you have one x star, so this will, so now how I explain this? So if it is x star will give you infinity, yes, including lambda. So now another x star will also give you infinity. Now two infinities are the same thing, so there is no difference in this one. So x star or x star or either x double star or how many stars on top, it is the same thing. It does not make any difference. If your base is same, so then it does not make any difference. But yes, if your base is changed, one is x, one is y, then it is not the same case.
Okay, thank you.
Okay. So now we have this thing. So now I have a question that with you here. Okay, I don't ask right now because you will be confused. So now we have this thing, this we are happy with this. So now we have this language A star, B star. I already explained that. You see lambda, because now what is A star? It is A star. If you see individually, what is A star? Lambda, A, two A's, B, two, three A's, and so on. And what is B star is lambda, B, and two B's, and so on. Now, if we write a language, so A will always be in the leading position, B will always be in the following position, and you might have lambda from here and lambda from here, this one, and two lambdas concatenate give you lambda. 1A, 1B, 2A's, AB, BB, 3A's, all possible combination. But you will never see if you have both A and B that B will be in the leading position. You will never see this. Always, if you have both A and B, A will be in the leading position and B will be in the falling position. So if you write A's before B's, remember A star or B star can always be lambda. So this is basically this language, and I already explained that A star B star is not equal to A B star. Okay, so this is very detailed information of this slide. Any question in this slide? Otherwise, I move to the next slide. No question, so let's go to the next slide. So now we have this language here, S odd, and we write the recursive definition of this language. We are saying that X is member of S odd, and if W is in S odd, then XXW is in S odd. So this is a language. So now how we write the regular expression of that? So we are saying that, so let's generate this language from this rule. So we have S odd and X by rule 1, X is in X odd, and rule 2 says if W is in S odd, W is any word, we only have one word which is X at this time, this is W, then X X W, X X and W is X is in S odd. So now next time if I reuse this rule again, this is my W, and it says that X X with W. What is W? 3X. Okay. So this way you can generate this language, and you can see that 1x, 3x, 5x, and every time it will add 2x there. So after 5, 7, 9, 11, this way it will grow, and this is odd language. Okay. So now we need to write the regular expression of that. So if you have this language, so how we write the regular expression of that? So this language says that uh, you will have 1x always be there, and then you grow always with addition of 2. So minimum you will have 1x. And how we write minimum we have 1x? Just by writing x. Minimum we will have there. And maybe we have, maybe we do not. And what does this mean? It means star, because star is the only thing which will give you lambda. So it means that something, whatever come here, should have star, because might be it is there, might be it is not there. Okay, and when it will be there, how many it will be? It should be considered as one entity. It is 2x. So now because star outside, this will always become in the multiple of 2, because star is not on 1x, it is outside on the parenthesis. So it means that it will consider this whole thing as one entity and then star on that. So whenever you repeat this, it will be repeat in multiple of 2. So x, 2x, then another 2x, then another 2x, then another 2x. This way it will grow. So now I can say x, I got lambda from here and I have only x. The next time I got one time xx, next time first x, and then I got this two times, one time, two times, see, and then so on. This way it grow, and this is a very nice regular expression we have. But you can replace its position here. So this is also good. So you can put this part before and put this after, because x is all basic unit is x. There is no separate thing a, b, x, y. So it does not matter that this come first or this come after, because here end of the day it is all x. So this is also thing, right? Or if you write this way, put this x in between. Oh, this is not right, this is different. Okay, so now first of all, do you understand this thing, that how we write this? So this is, I just explained that. So now my question is, if we have x star x x star, this is not equal to this and this. Why? Because now you see, what does it mean? It is not outside the bracket, it is inside the bracket. It means this x has separate star, this x has separate star, this x has no star. So when one x has no star, this gives you guarantee that you will not have lambda, but you will have one x will always be there. Okay, very nice. Now what is the next step? So now if you see this x star, what is this? It is lambda x and all two x's and three x's and so on. The same is another case. So might be I pick lambda from here for this x star, and I pick lambda from here from this x star, and I will get x, because this x will always be there. It does not have any sign. So might be I pick, so the next thing x is always be there, this x. I pick lambda from here and I pick 1x from here, 2x. Whereas this is not a case in our language. It should be odd. So this is the reason that x star x star is not the regular expression of the odd language, because it is possible to get 2x here. It is possible to get 4x from here. So that's why it is not equal to this thing. Make sense?
Yeah, that makes sense.
Okay, very nice, guys. Thank you very much. So now this is regular expression, and gradually we will increase its complexity. So now if you see this, we will see the plus sign here. It says that, so now you will see the new usage of plus sign. Before you see plus sign, we use that for the uh, positive closure property. Now we will use this as an OR operator. So it means that when you write plus sign among two letters, so it means that either X or Y, you will never see both things there. So it will be either choose this path or choose this path. It's not possible that choose both parts. You have choice. It's not mandatory. It is not and, but you can but you are only choose one path. Either this, if you choose X, you will not able to choose Y. If you choose Y, you will not able to choose X. So only choose one path. You have a choice there. So now let's say we have summation is equal to ABC. It means that we have three basic building blocks. First time we are looking now three letters. Before we only see A and B. And now we have this language. And we are asked to write the regular expression of this language. Okay, let's say I do not see this. So now I need to understand first the pattern of my language. What is the pattern of my language? I can see that it starts, so there is no lambda. It means that whatever the regular expression I will write, altogether outside, you will never see something like this. Because if you have this thing, it will give you lambda, because this whole thing will be part of either you have this or you do not have this. It means you will never see something like this. Okay, so you can see that you have only A there, Now I am looking at this line. So you have only A there, the first thing, then you have only C there. You do not have only B there. Okay, but B, then you have combination of A with B. So B is in the falling position, A in the leading position. B and then CB. So again, if B can come with C, C is in the falling position, leading position, B in the falling position, and A and C only come one time. If it be there, it must be there, any one of them, and B may be there, may not be there, and B can grow as many times as you want, 2 times, 3 times. So this means, so now it means that our word will always start from either A or C, and after that we may have or may not have B. How we write this? May or may not by B star, and might be we have this B as many times. So star will give you this provision of lambda and 1 time B or 2 times B or 3 times B. So this is the regular expression of this language. We have a word which always start from either A or C. You will never see A and C both together in your language. It may have after that B, or it may not have, and it may be, if B will be there, it might be 1 time or as many times. So this is the regular expression of this language. So it's, if you see, this defines the language whose words are constructed from either A or C followed by some. So now whenever you have this star, how you define this in English language, followed by some B's. Because if you write followed by B's, it does not mean that lambda will be there. You are making sure that followed by B's. You are not saying maybe or some, but by writing some, it means that maybe one B or maybe no B's or maybe more than one B's, followed by some B's. Okay, so this is basically the right English language for writing, for to express that there is a star on that. And if you do, if so, it's, I suggest that you mention this way, which followed by maybe or maybe not some bees. That will be more accurate. Okay, so we are happy with this. If you have any questions, so you can ask. Otherwise, I'm going to the next slide. So now, we done the regular expressions. Now we will see some more examples, and you can, and gradually we can increase the complexity of examples. So now this is your language, and if you see this language, so what is this? If you write this in English language, how we can say that we will see only A's will be there, only B's will be there. It start with A and then A, B start with. So if you see that it's all possible combination of 3 letters. A will be, if you see here, the first letter will be A, the and the second letter will be A also. First letter will be B also. Second letter will be A also and B also. Third letter will be A also or B also. So now, or you have only A's or only B's. So now it means that A or B can come at any location of first place, second place, or third place, any location. And it might be possible you do not have A's or you do not have B's, only A's and only B's. So all words of exactly 3 letters from the alphabet A comma B. This is a this is the English definition of this language. And I just explained you, if you see that the first letter of each word in language is either A or B, same is the case with the second position of the word, and the same is the case with the third letter of each word in this language. It can be A or it can be B. So now, in short, we can write this way: the first letter of this language, if someone asks me to write the regular expression of that, so I can say the first letter will be A or B, second letter will be A or B, third letter will be A or B. This is the very nice, fine, correct regular expression of this language. Make sense? but it looks good to your eyes. It is not required, but I mean, when you get more expert, in short, we can say that A or B can come 3 times by any means. Okay, so it means that either A can come 3 times or B can come 3 times, or 3 times you can use this set and choose any of this option. It is the same thing. Okay, so now if I have 3 times, so any confusion in this? How we get A plus B 3 times? Quinton, do you happy with this? Do you understand this thing? How we get 3 times? Very nice. So now if I increase this to 5 times, what does it mean? I am increasing the length of my word. Instead of 3, it will be 5, but the answer will be same. So now A plus B 5, what does it mean? That the length of the word will be, so 1, 2, 3, 4, 5, and then all possible combination, like B can come anywhere, A can come anywhere, all possible combination of A and B in maximum length is 5. So now if I say that instead of 3, instead of 5, A plus B whole star. So what does it mean? It means that it is a universal set. So it is, now how it will be if I write this. So now let me write this in this format. So when I write A plus B whole star, all words formed from alphabet A comma B. So A plus B whole star means uh, you can have, it does not gives you guarantee of 3 words, because if you put 3, it makes sure that maximum or minimum three letter word. So if it is 5, you will never have one A there or 2 A's there. You must have 5 letter word there. 3 means 3 letter word must be there. But when you have star give you flexibility. You might have lambda, you might have only A, you might have only B, you might have 2 letter word, you might have only 2 letter B, you might have A B there, you might have B A there, and so on. Infinity. So this is a universal set. You can have any letter of word there, it does not matter. And this can be everything possible with A and B, either one letter, A, it start with A, it end with A, it start with B, it end with B. It has only A's, it has only B's, it has 1,000,000,000 A's, 1,000,000,000 B's, and lambda, and everything is, this is a universal set, infinity with respect of A and B, only when you have star A plus B whole star outside. Make sense? I think that this is easy now to understand, because you understand this. So now, so please ask me a question if you guys have any confusion here, because you will need to write the regular expressions by yourself, and my feeling is that students always stuck with that, and there you lose the points. So please ask me a question if you do not understand. So now I have this, uh, we figure out this thing. So now when we have A plus A here and this thing, what does it mean? So how I write the language of this? So anyone? So start, can you please help me to write this? A and then A plus B whole star outside.
So for this one, it's basically the same as the last one we did, except there's no lambda.
This one?
Yeah, right? Or
But
oh no,
you're
because
very
we'd
close.
always
It has A here, yes?
as an A. Yeah,
So
that's right.
it means that A will always, first you are right. First of all, there is no lambda. Why there is no lambda? Because this A has no sign on that. So this is 100%, you perceive it very right, correct? That lambda will not be there. But this gives you one restriction. all words start from A. After that, I do not care what happened. So all words start from A. Might be from this whole thing you will get lambda, and you just A there because of this A. And then any combination of this thing, A, B, and um, all possible combination after that. Everything is possible. So all these things exact but start with A. So you will never see a word which start with B here because A is there in the start. Make sense?
Yeah.
Very nice. So now if you see this, so now we use A plus B star to beef up the language always. Whenever you want to say, I do not care what pattern, I do not care lambda will be there or not. A will come as a start, or only A's or only B's. Start with A, start with B, end with A, end with B. A will come in between A, B, A, B, A, B. Anyways, any combination. So that then we refer that to A plus B whole star. Okay, it is infinity and all possible combination. But this gives you guarantee always words start with A. After that we don't care. This gives you guarantee all words of this language will start with A always, always end with B. In between, I do not care whatever the term you pick from here and put there. I do not care. It is A plus B whole star. So all words start with A, end with B, and in between might be just A, B. No lambda will be there, first of all, because no sign here, no sign here. Might be you get lambda from this term, but lambda with A and B will vanish and you will get only A and B. And then A after in between A and B, another A, in between A and B, another B, in between A and B, another two A's. As you wanna grow, it does not matter. But all words will start from A and end with B. Does not matter whatever the size of the word, because in between it has A plus B whole star. A plus B whole star is infinity. You can pick any size of word from A plus B whole star, and you can pick any combination of A and B with that. So I think that you guys understand this. Any question, guys? Okay, no questions. So see, we have lion here. Lion left or what? He left. Okay. Okay, this is good. So now let's go to the next slide. So we are saying that regular expression. So the formal definition of regular expression. So whatever we just did, so how we define this in a formal language. So given an alphabet summation, the set of regular expressions is defined by the following rules. For every letter in summation, the letter written in bold is a regular expression. Lambda is a regular expression. If R1 and R2 are regular expressions, then so are. So if you have two regular expressions, so you can put parentheses around that. It will still be regular expressions. If you have A is so I have a language. So now I have a. So can you tell me a regular expression for a language which will just have one word A? That's it. No more than one word. That's it. Only one word A. So what is the regular expression of a language which will have just one word A? Darian, what is the regular expression of this language? I have a language which has just one word A. So I unmute your mic, Darian. So what is the answer of this?
I don't know.
I mean, it's very simple. So you have a language which has only one word A. That's it. So Gunnar, can you answer this question?
It just has A.
Amazing. Very nice. Just one A. That's it. I have a language which has anything, lambda or okay, I have a language which has anything, let's say lambda or 1b or 2b's or 3b's, any number of b's. So what is the regular expression of this language? Jacob Morris.
What was the question again?
I have a language which has lambda, 1b, 2b, 3b's, 4b's, 5b's, infinity b's. What is the regular expression of this language?
Would it be B star?
Amazing. Very nice. It is B star. So now we are saying that if we have two regular expressions and we concatenate two regular expressions, this will not change its behavior. It will still be a regular expression. It will be a new language. It's a different language, but it will be a regular expression. And if you have two regular expressions and you put or sign in between either this regular expression or that one, it will still be a regular expression. And if you take the closure property of a regular expression, so let's say A and you put star here, so this will still be a regular expression. It will not change the behavior of it will be a new language, but it will not change its behavior. It will still be a regular expression. So nothing else is regular expression other than these two rules. So if you want to write the language for the regular expression, how you recursive rule, so this is the recursive rule of the regular expressions. So now R1 plus is not included because so R1 and R1 star includes the R1 plus, because R1 plus means you must have R1 there and then any combination of R1 with itself. So R1 and R1 star is equal to R1 plus. It is the same thing. So that's why we did not include plus sign in this definition. Okay. So this is a recursive definition of the language. And then we are going to here, next slide. So corresponding languages that are so now whenever you have regular expression, we always say so far it will define a language. Now what is this language? This will be there are number of languages. There are regular languages, there are non-regular languages, there are context-free languages, there are context-sensitive languages, there are formal languages, there are so there are number of languages. So which language we are talking about? There are non-regular languages. So regular expression always represent regular languages. Okay, regular expression always represent, refer, define regular languages. So this language defining tool is of very limited capacity in that there are many interesting languages that cannot be defined by regular expressions. Regular expression has a limited ability. It is only used to define the regular languages. It is not possible. Regular expression does not have ability, does not have capacity to represent, to define any other language than regular languages. Like it is not possible if I ask you write a regular expression for non-regular languages. That languages have very big scope. It is not possible to define the regular expression for non-regular languages. It is not possible to define the regular expression for context-free languages. It is not possible to define regular expression for context-sensitive languages. So it is if you have a language and you have a regular expression of that language, it means that it is a regular language. It is not possible that you can write a regular expression of any other language. Okay, so this is very important, that regular expression refer to a regular languages. Okay, this is very important. And And then we are saying that two regular expressions, equivalents of regular expressions. So the two regular expressions are equivalent if R1 is equal to R2, if and only if they represent the same language. So now it is possible that we have two regular expressions. They look different, but they both define the same regular language. Okay, let's see this. We have one regular expression which is x plus, this is, if you write the language of this, it will be 1x, 2x, 3x, and so on. Okay, we have another regular expression which is x and x star. It represents 1x, then 2x, and 3x, and so on. So you see, we have two regular expressions, but they are different from each other, but they represent the same language. They define the same language. When you have two regular expressions, but they define the same language, then we can say that these regular expressions are equal to each other. Okay, they are equal to each other. This is what we try to explain here. So now we have, let me show you one example here. So a plus b whole star a, and then a plus b whole star. So first of all, how we write the what is the, how we write the language of this regular expression. If I ask you what is the language of this regular expression, so can anyone help me to fill this? So Jacob Sorensen, can you help me to guess that what will be the possible words of this language?
Um, any number of A or B before an A, and then the same thing with any number of A or B after the A, or it could just be a single A.
Can we have lambda here?
We cannot, since
We
there will
cannot.
always be an A in the center of the language.
Excellent, excellent, perfect. So we will have one A, and we do not care what come before that, what come after that. Whatever the word, this language, this regular expression gives you guarantee that one A must be there. We don't care what come before that, what come after that. Okay, so this is basically the regular we can define this way. You can write anything in there, but one A must be there. So it will never have all B's, it will never have so like that. So of all words that have at least one A, we don't care what come before, we don't care what come after that. So if you have this is a very nice word. It is possible in this language because it has minimum one A there. So now this is a valid word. If you make a factor of this, so you can say that you will receive lambda from this part, and this A you will receive from here, and this thing you receive from this part. Okay, so you make a factor of this because it second, so this any way you make a factor, so this part from the first part A, and then third part, so this way you can make factor of that. Okay, so now we have a regular expression. Summation is equal to A comma B, and I want to write a regular expression which does not have any A's there, just B's. So it is B star. Okay? Because B star will give you guarantee that there is no A there, and it can have lambda also, and it can have, if it is not lambda, if it is just B, so it can be any number of B's there. Okay, so do you guys understand this? Yes. So now we have all words formed from A, B, and now we are saying that what if you combine this regular expression? Let me clean this screen for you. So we are saying that what if we combine this regular expression and this regular expression? What it will give us? So now look at this. So this will says that we will have minimum one A must be there. And what, so now my question with you is, which terms are missing in this regular expression? So which terms are missing in this regular expression? What will be the word which will not be there? Give me one example that this word will not be there. James Evans, which word is not be there in this language?
Like BBB would not be there.
Yes, only those words which have just composed of B, either one B or as many B's, but there is no other letter with that. So A will not. So it means that if you, but other than that, it has all possible words. Yes, and so now it means that if you add with this regular expression this thing B star, look at this, I write the same thing here, and B star, so now this is equal to what? This is equal to A plus B whole star. Make sense? Now this regular expression whole thing is equal to A plus B whole star, because A plus B whole star says lambda will be there, we can get lambda. So now if I have this regular expression, can we get lambda?
Yes, because now with B star, we can get lambda.
Okay, so let me see. James Rodriguez, how we get lambda from here? James Rodriguez. James, are you there? James Rodriguez. Evan, are you there? What's going on, guys? You guys are not there? Luke.
Hello, I'm here. What was the question?
So question is this, can we get lambda with this regular expression or not? Sorry. With this.
Yes, because of the B star.
So how we get lambda from B star? We have all this thing also here.
Yeah, and then the plus is like an or, so you can just have what's on the right side.
Perfect. You are right. So you have a choice. Either you choose this part of the regular expression or this part of regular expression, and this part and has lambda there. So we choose, if we just ignore this part and we choose this part, we will get lambda in our regular expression. And this is equal to A plus B whole star. So now if I ask you this question, I said, okay, this is A plus B. Look at this. I give you question this way. I will ask you A plus B whole star, A plus B whole star. I will ask you, can you please find the missing terms in this and make it complete for A plus B whole star? So this will be a question. So I will give you some regular expression and I will ask you, can you please make it complete for A plus B whole star? So what does it mean? Your job is to find what is this regular expression, what terms are missing in this regular expression, find that, and find whatever the terms are missing, what will be the regular expression for those missing terms, and write the regular expression of that and make it complete and make it equal to a plus b whole star. So now if I add plus b star in this, so this is now equal to a plus b whole star. Okay, and look at this, it is there. I will ask you this question in exam. I will give you one regular expression that is not equal to a plus b whole star, and I will ask you that find the missing terms and make it complete for a plus b whole star. So what mistake you will do? Instead of writing b star in after plus sign, you will write a plus b whole star. No, I do not want this. This is everything. I don't want any repeating term. I want all only for the missing terms. So write the missing terms regular expression here, and which make it complete for a plus b whole star. This is what I want. Okay, so this is our question answer of this. So now if you see this, if you see this part, it is all strings with an a, and if you see this part, all strings without an a, and this means that all strings now, if you have all strings with an a and without an a, if you combine that, it is all strings. And this, what is this? A plus b whole star. So this way you can make it complete for a plus b whole star. Okay, so this is good. Any question, guys, here in this slide? Question? Okay. Now we are saying that the language of all words that have at least two A's. So now you need to understand this thing. The language of all words which has at least two A's. It does not say two consecutive A's. It does not say start with A and end with A. Simple. Language of all words that have at least two A's. It means we wanna expect. So now what is the thinking process of writing the regular expression? So first we write what is minimum required for this definition. So it says minimum at least two A's. And it, so now if we read this, this gives us this information. Word, it does not say that word start with A or two A's, word end with A, or two A's are the consecutive A's, nothing can come in between. Anything, word can start with A, word can end with A, anything can come in between. These two A's will be anywhere in your word, anywhere. So now minimum requirement, this is at least two A's. First you write the minimum requirement of your regular expression. So now I have a word which has at least two A's. So this gives, if when I write two A's, this gives me this guarantee two A's must be there. Very nice. And then it does not say anything that from where it starts, from where it ends, from where what happened. So anything can come before this, anything can come after this, anything can come in between this. You see, when we write this, this is a perfect regular expression for at least two A's. So this is the thinking process. First write the minimum part and then make it complete for with the according to the definition. So this is mandatory thing. First we write that, and then we make it complete according to the definition, and then this is the perfect regular expression. At some stage when you become more familiar, more experienced, guys, then you will figure out that it has some repeating terms. So this is also, if you write b star a, b star a b whole, a plus b whole star, this is also the same thing. It represents the same thing. This also represents the same thing. This also represents the same thing. So these are more clever, intelligent, nice, precise, accurate way of writing the regular expressions. But I don't expect that you will learn these very soon, because this will come with the experience when you are very much experienced of writing the regular expression. So if you write this regular expression in class, I am fine with that. I have no issue. So I mean, this is also correct and actually more good. But if you come with this initially at this stage, I have no problem with that. So I don't care that it is more precise or accurate. If you write in a way, it solves the purpose. The two expressions are equivalent if they describe the same language. The language of, so now this is good. So any question with this, at least two A's, no problem. So now we are saying that we need to write a regular expression for exactly two A's. The language of all words that have exactly two A's means whatever the size of the word, you will never have less than 2a, you will never have more than 2a's. Here it is at least minimum. You may have more than 2a's, but minimum 2a's must be there. Here exactly 2a's. So first exactly 2a's. It does not says word start with a, word end with a, nothing can come in between, consecutive 2a's. No, it says exactly 2a's. Okay, so we have exactly 2a's minimum requirement we fill, and then it does not say that anything cannot come. Anything can come. So when we do not have anything here, we will assume that summation is equal to a comma b. This is I already explained you that this is a default understanding. So anything can come before that. What is that? B star. We will never say a plus b whole star, because if you put a plus b whole star, it means you can have more a's there also, but it will violate this. It has exactly two a's. We can have b star after that, we can have b star in between. So now it has exactly two a's. It can start with b, it has beef up with in between b, it can end with as many b's, maybe no b's, just two a's, but you will never have more than 2a, you will never have less than 2a. So this is exactly 2a's. Okay, so this is the regular expression of this. And then let's see here. So we are saying that at least, so now this is another, we are saying we need to write a regular, so any question guys here so far? Then I move to the next step. How much left? 2, 3, it's not too much. So I think that I should stop here, and I should not go to the next one, because if you absorb this, it will be too much, and this will be great. What I will do, I will post, so chapter 4, I will post assignment for which will be made, which will be composed of include chapter 1, 2, 3, 4, first assignment. But chapter 4 is not finished completely. So you start working on that, because it has some questions from chapter 1, chapter 2, chapter 3, and chapter 4, whatever we covered, you can start working with that. But I will cover the remaining slides, and then you will be able to finish that slides also. So now you need to understand that we only have 6 weeks, so I cannot extend the assignment. I cannot give the weeks for the assignment. You have to do this in few days. So assignments are a bit long, and my exam will be exactly like the assignment. So this is good thing. So please start working on the assignment. I will post it today, right after this class, and then we will see that what should be the due date of that. It will be somewhere Tuesday or Wednesday. Okay, because most of the material we cover, and this assignment will be from first 4 chapters. So once we cover the chapter 4, then we will have another quiz from chapter 3 and chapter 4. Okay, do you I think that this is a good idea to post assignment now, because you will have weekend, so you can at least finish major part of that, and few questions left, and then you can finish in 1 or 2 days after that when we finish chapter 4. Don't forget that you need to attempt the quiz today. It is available from morning 8 o'clock till evening 5 o'clock, and then it will not be available. I will not extend the quiz. I will not allow you to do the quiz, because once the quiz will be done, I will post the solution of the quiz online in your Canvas. You can see there. So then once I posted the solution, so then no one will allow to retake the quiz. Okay. So I think that that's it. Please read this, and if you have any question, come back, ask me the question on during this week also. If you are struggling with assignment, so you can send me email. I can come online and we can do the meeting, or I can try to answer in email, or any way you like. Okay, so do not worry about the office hours. Okay, guys, thank you very much.